The last lecture we discussed the GLB and LUB, the greatest lower bound and least upper bound. Now we use the greatest lower bound and least upper bound to define the lattice. So just recall the definition of lower bound and greatest lower bound. What is the lower bound? Lower bound means element of the poset which is related to the all element of the subset. It is called lower bound. And if we have the uh, in a all lower bound are related to the one lower bound, that lower bound is called greatest lower bound. Similarly, for upper bound, the all element of the subset, it is related to the one element of the poset. That element is called upper bound of the set uh, of the subset. And from the all upper bound, the one upper bound is related to the remaining all upper bound. Then that upper bound is called least upper bound. Okay. So now we use the GLB and LUB. We define this for the only the subset. If we have the poset and the subset is given, then we find the lower bound, greatest lower bound, upper bound, and least upper bound of that subset. But suppose the poset is given, and we want to find the GLB and LUB of two elements. Then so for that we have the GLB and LUB are defined for different relations. Now first we define the lattice using Poset, then we take the GLB and LUB for a three relation, that less than or equal to relation, subset relation, and the device relation. Okay. So the definition of lattice as Poset is, if we have the poset A comma R, it is called lattice as a poset A. The GLB and LUB of any two elements in A are also belongs to the capital A. Means GLB and LUB of all elements of the set A are belong to the set A. Then it is called lattice as poset. Okay. It is called lattice as poset. If there is any one element is not in A, then it is not a lattice. Okay. Now, for lattice, we defined here GLB. Say we denotes the GLB of two element A comma B by A star B. Okay, this is a notation for GLB. This is a notation for GLB, and this is notation for LUB. So if we have the LUB of A comma B, it is defined. It is denoted by A ring sum B. Okay, this sign is called ring sum. This is a ring sum, and this is a star. Okay, then now we take the GLB and LUB of the standard relations. So first we have device relation. So if we have the device relation, then GLB of two elements, it is a GCD of two elements. Means if we have the poset is given uh, S30 comma D. Suppose S30 comma D is given, then GLB of uh, 10 and 15. It is a GCD of 10 and 15. So it is equal to, we have What is the GCD of 10 and 15? What is the GCD of 10 and 15? Write in chat box. What is the GCD of 10 and 15? What is the GCD of 10 and 15? GCD means greatest common divisor. You can write as a highest common factor, HCF. GCD means so GCD is a 5. Okay, greatest common divisor. So 5 is divides 10 and 5 is divides 15. So GCD of the 10 and 15 is a 5. So here we have GLB is a 5. Okay. Now what is the LUB? So LUB of A comma B is a LCM of A comma B. So what is the LUB of 10 and 5? LUB of 10 comma 5, sorry 15. It is a LCM of 10 comma 15. So it is a LCM of 10 comma 15 is 30. Okay, 10 divides 30, 15 divides 30. So LCM is a 30. So here the LUB of 10 and 15 is a 30. Okay. So remember this, when we have device relation, the GLB is a GCD of two number, LUB is a LCM of two numbers. Okay. Then second we have the relation is a less than equal to. So in less than equal to relation, we take the GLB is a minimum of AB and LUB is a maximum of AB. So if we consider here the Z comma less than equal to, it is a poset. Yes, Z comma less than equal to is a poset. So we have the GLB of 4 comma 9. It is a minimum of 4 comma 9. So from 4 and 9 we have 9 is 4 is a minimum number, so answer is a 4. So GLB is a 4 and LUB is a LUB 4 comma 9 is a, we have maximum of 4 comma 9. So maximum number is a 9. So LUB is a 9. Okay. So remember this, for less than equal to, GLB is a minimum number, LUB is a maximum number. Okay. Then the third relation is a subset relation. So for subset we have GLB is a intersection and LUB is a union. Okay. So if we have the P of A, suppose P of A comma subset is given, where A is a A, B and C. Okay. Then we have here GLB of singleton A comma singleton B. It is singleton A intersection singleton B. So the intersection is phi. So here GLB is a phi and LUB is a LUB singleton A comma singleton B. It is equal to singleton A union singleton B. So union is a two terms A comma B. So it is a LUB of the A comma B. Okay. So when we have the subset relation, we have GLB is the intersection, LUB is a union. Okay. And mostly we use this three relation because we know that S and comma D, it is always Poset. Then for less than equal to, it is always Poset. P of A subset, it is also Poset. Okay, so mostly we use these three relation for checking lattice. Okay. नीलेश क्या प्रॉब्लम है? नीलेश हाँ बोलो.
हेलो सर. सर आपकी स्क्रीन नहीं दिख रही है, इसमें नेटवर्क प्रॉब्लम है कि क्या है पता नहीं चल रहा. क्या पता, मुझे तो नहीं दिख रही है. प्रेजेंटिंग तो दिखा रहा है.
सबको स्क्रीन दिख रही है कि नहीं? बाकी सबको है, मतलब तुम्हारे में नेटवर्क प्रॉब्लम होगा.
ओके सर, जो आपने समझा है ना वो समझ में नहीं आया, इसलिए दिख नहीं रहा है. इसलिए
और एक काम करो, जहाँ पे नेटवर्क ज्यादा आता है वहाँ पे चला जाए, या फिर एक बार है ना मोबाइल में एरोप्लेन मोड करके फिर से ज्वाइन करो.
ओके सर. ओके.
ठीक है, तो ये तीन रिलेशन के लिए ये तीनों याद रखना. तो भाई अगर डिवाइस रिलेशन दिया है तो दो एलिमेंट का जीएलबी होगा, जीसीडी, एलयूबी होगा, एलसीएम. अगर लेस देन इक्वल टू रिलेशन है तो दो एलिमेंट का जीएलबी होगा, मिनिमम एलिमेंट, और एलयूबी होगा, मैक्सिमम एलिमेंट. अगर सबसेट रिलेशन है तो दो एलिमेंट का जीएलबी होगा, इंटरसेक्शन, और एलयूबी होगा, यूनियन. ठीक है. तो अब जितने भी एग्जांपल्स आएंगे लेटाइस के, चाहे वो इसमें लेटाइस यूजिंग द पोसेट हो, या इसके बाद का टॉपिक है लेटाइस यूजिंग लेटाइस बाय एल्जेब्रिक सिस्टम. तो उसमें भी ये याद रखना है कि भाई दो एलिमेंट का अगर डिवाइस रिलेशन है तो जीएलबी जीसीडी होगा, एलयूबी एलसीएम होगा. ठीक है. लेस देन इक्वल टू में जीएलबी मिनिमम, एलयूबी मैक्सिमम. सबसेट में भी जीएलबी इंटरसेक्शन, एलयूबी यूनियन होगा. ठीक है. तो इसके साथ मतलब ये जो है, इसके साथ हम फोर्थ प्रॉपर्टी, जो पोसेट प्रूव करने के लिए हम तीन प्रॉपर्टी प्रूव करते हैं, दैट आर इज अ मीन्स रिलेशन इज अ, जो रिलेशन है वो रिफ्लेक्सिव होगा, एंटीसिमेट्रिक एंड ट्रांजिटिव. इफ द रिलेशन इज अ reflexive, antisymmetric, and transitive, then we say that the given set is a poset. Okay. So after proving the poset, now we prove the one more property, that if we have the inner set for each, for all pair of, means possible all pair of the um, element of that set, the GLB and LUB are also belongs to the same set. Like S30 is given, then S30 has the elements. We have the in a S30 we have the elements are 1, 2, 3, 5, 6, 10, 15, and 30. So we prove that the GLB and LUB of this all elements, if you take the any two element from this, then GLB and LUB are also belongs to the S30. Means it is a among these elements. Okay. So if we can prove this one, then the S30 comma D is a latex. If there is a any two elements are there exist such that the GLB is not possible, means sorry, LUB is not in a set, then we say that it is not a latex. Okay. Now we take the examples so you can understand this easily. We have the first example is a S30 comma D is a lattice as a poset. So here the first way how to prove that S30 comma D is a poset, और वो हम बहुत बार कर चुके हैं, तो इसलिए ये क्वेश्चन जो है पोसेट प्रूव करने का वो आप पे बोल रहा हूँ। आपको मैं अभी 12:24 हुआ है, 12:28 तक का टाइम देता हूँ। 3 मिनट में आप वो प्रॉपर्टीज एक बार प्रूव कर लो। अगर नोटबुक में लिखी है कहीं पे तो वहाँ पे जाके देख लो, ठीक है, जल्दी से। नीलेश आगे जो एग्जांपल करेंगे ना उसमें फिर से वो सब रिपीट होगा ही। ओके। अरे तुझे वही तो बोल रहा हूँ कि आगे फिर से वो रिपीट होगा, समझा दूंगा। अभी जो करना है वो सिर्फ ये है, पोसेट करना है। पोसेट तो प्रूव करना तो बहुत पहले हो चुका है ना। पोसेट पे क्या आ गया प्रूव करने में, दैट we take the two any element x belongs to S30, then x can be written as 1 into x, so that therefore x is divides x, so it is a reflexive. The second we have x comma x is not equal to y, x not equal to y belongs to S30, and x divides y, that means x is less than equal to y, sorry, s is less than y, not equal to, because we already taken s is not equal to y. So x less than y, so therefore y cannot divide x. So it is anti-symmetric. Okay. Then if we have x comma y comma z belongs to S30 and x divides y, y divides z, so that will give you y equal to some mx and z equal to some ny. Okay, so in a z we can replace the z equal to n into mx, that is a n into m into x, so that give you x divides z. So it is a transitive also, so therefore S30 comma D is a coset. Okay, ये क्वेश्चन मोस्टली 6 मार्क्स में पूछा जाता है, यहाँ 8 मार्क्स में आता है। तो जब भी ये 6 या 8 मार्क्स में है तो पहले ये 3 प्रॉपर्टी आपको प्रूव करनी है। ओके, so this prove that S30 comma D is a coset. Now we prove that it is a lattice. So to prove the it is a lattice, we have to prove that the if we take the any two element from S30, then LUB and GLB of that two element are also belongs to the S30. So what is a LUB and what is a GLB for a device relation? What is the LUB and what is the GLB of device relation? डिवाइस रिलेशन के लिए जीएलबी और एलयूबी क्या है? जीसीडी एंड एलसीएम. डिवाइस रिलेशन के लिए जीएलबी है जीसीडी और एलयूबी है एलसीएम. So here now to prove that all A comma B belongs to S30, GLB it is a GCD of AB and LUB it is a LCM of AB belongs to S30. ठीक है, ये सबको याद रखना है कि अगर डिवाइस रिलेशन दिया है तो GLB होगा GCD और LUB होगा LCM. ठीक है, अगर डिवाइस रिलेशन है तो GLB आएगा GCD, LUB आएगा LCM. Okay. Now to prove this one, we make the one table. Here S30 is a these elements 1, 2, 3, 5, 6, 10, 50 and 30. Now we make the table for GCD. Here say here in this one, here we write GCD of AB. Here in this first row we write the elements of S30. Here also we write the elements of S30. Now here in between this we write the GCD of the A and B. Okay, A means the row element, B means column element. So here the first we have 1 comma 1. So what is the GCD of 1 comma 1? A equal to we have 1, B equal to 1. So GCD of 1 comma 1 is a 1. Okay, greatest common divisor of 1 comma 1. So it is 1. Then greatest common divisor of 1 comma 2. This is a, here we have A is a 1, B is a 2. So GCD of 1 comma 2 is a, so GCD of 1 comma 2 is a 1. Okay, because here 1 divides 1 and 1 divides 2. Okay, so greatest common divisor is a 1. So whenever we have the 1 in place of A or B, the GCD is always 1. So that's why you have to see in first row here we have all have a GCD is a 1, and also in this column GCD is always 1. Okay, whenever we have A or B is a 1, either A or B is 1, the GCD is always 1. Okay, so the first row and first column is a 1. Now here here GCD of 2 comma 2 we have 2. What about the GCD of 2 comma 3? GCD of 2 comma 3 is a GCD of 2 comma 3 is 1. They are co-prime number. Okay, 2 does not divide 3, 3 does not divide 2. So we have they are co-prime numbers. Okay, common factor is a 1. Then GCD of 1 and 2 and 5 is also 1. Both are prime number. So GCD of 1 and 5, it is a 1. Sorry, 2 and 5 is 1. Now 2 and 6, then GCD is a 2. 2 and 10, so again common divisor is a 2. For 2 and 15, the common divisor is 1. Greatest common divisor is 1. For 2 and 30, we have 2. Okay. Then we take for the 3. So 3 and 1, 1. 3 and 2, 1. Okay, this is a symmetric, we got symmetric values. So here we have 1, 2, 3 and 3. 3 and 3 is a 3. 3 and 5, GCD of 3 and 5, it is 1 because both are prime number. 3 and 6, then GCD is a 3 here. Okay, GCD कैसे फाइंड करते हैं वो लास्ट लेक्चर में भी एक बार देखा था, फिर से देखा देता हूँ अगर ना याद हो तो। GCD कैसे फाइंड करते हैं, जैसे मुझे 10 और 15 का GCD फाइंड करना, तो मैं GCD कैसे फाइंड करूँगा, 10 लिखना है, यहाँ पे 15 लिखना है। ओके, कॉमन जिससे डिवाइड कर सकते हो वो फाइंड करना है यहाँ पे। सॉरी, यहाँ पे नहीं, थोड़ा तो 10 को डिवाइड करने के लिए 2 से डिवाइड होगा, 2 यहाँ पे 5 आएगा, देन 5 को 5 से डिवाइड करो 1। तो 10 में हो रहा है 10 इज अ 2 इंटू 5। ठीक है, 15, तो 15 में 3 से डिवाइड करना पड़ेगा, तो 3 से डिवाइड करें तो यहाँ पे 5 आएगा और बाद में 5 से डिवाइड करो 1 आएगा। तो 15 जो है उसमें उसका आएगा 3 इंटू 5। नाउ हियर 5 इज कॉमन इन अ बोथ, so GCD of 10 comma 15, it is a 5. And what is the LCM? तो LCM कैसे निकालना है, तो LCM है वो इन LCM के लिए ये मेथड यूज करना, यहाँ पे 10 and 15 दोनों साथ में लिखना है। Now first we divide by 2, so if we divide by 2, this is a 5 and this is a as it is 15 because 2 does not divide the 15. Okay, then we divide by 3. If we divide by 3, 5 as it is because 3 does not divide 5, but here 3 divides the 15, so here we have 5. Now we divide by 5. So we got here at the both place we got 1 1. When we got 1 1, multiply this the prime numbers, it is give you the LCM. So 2 into 3 6, 6 into 5 30. So 10 and 15 has a LCM is a 30. ओके, तो इस तरह आपको जीसीडी और एलसीएम फाइंड करना है. ठीक है, इसको भी अगर याद नहीं है तो इससे एक बार समझ लेना. ओके, जीसीडी और एलसीएम फाइंड करने के लिए आपको उसके प्राइम फैक्टर्स फाइंड करने हैं. प्राइम फैक्टर्स में जो कॉमन प्राइम नंबर्स आ रहे हैं वो आपको जीसीडी देगा, और एलसीएम के लिए आपको कॉमन प्राइम नंबर्स का मल्टीप्लिकेशन फाइंड करना है. यहाँ से भी आप एलसीएम फाइंड कर सकते हो. ये जो हमने फाइंड किया ना, ये यहाँ से भी आप एलसीएम फाइंड कर सकते हो कि भाई 10 में 2 एक बार आ रहा है, तो एक बार 2 लेना है एलसीएम में. 5 एक बार आ रहा है, यहाँ पे भी 5 एक बार आ रहा है, तो 5 एक ही बार लेना है. और 3 एक बार आ रहा है, तो 3 भी एक बार लेना है. तो एलसीएम हो गया 30. ओके, तो इस तरह आपको एलसीएम और जीसीडी फाइंड करना है. ओके, ओके. तो पूरी तरह ये जो टेबल है उसमें सारे एलिमेंट्स चेक कर लो, सबके जीसीडी. जितने भी सब एलिमेंट्स के जीसीडी है वो सारे एलिमेंट्स S30 में है. एक भी एलिमेंट ऐसा नहीं है जिसका जीसीडी S30 में ना हो. तो मतलब सबके जीएलबी, ठीक है, सभी एलिमेंट्स के जीएलबी S30 में प्रेजेंट है. ओके, नाउ यू हैव टू फाइंड द एलसीएम. सो जैसा ये जीसीडी वाला टेबल बनाया उसी तरह आप एलसीएम का टेबल बनाओ और सारे एलिमेंट्स के एलसीएम फाइंड करो और चेक करो सभी एलिमेंट्स S30 में आ रहे हैं कि नहीं. चलो जल्दी से सब लोग टेबल बनाओ इसी तरह का S30 के एलिमेंट्स का एलसीएम के लिए, और एलसीएम चेक करो सबके वो S30 में से ही है या नहीं. जिसका टेबल बन जाए वो चैट बॉक्स में डन लिख देना. उसके बाद आगे एग्जांपल करते हैं. एलसीएम के लिए सेम टाइप का टेबल बनाना है और चेक करो सारे एलिमेंट्स S30 के हैं कि नहीं. एलसीएम फाइंड करना है था, जैसे अभी हमने जीसीडी किया ना उसी तरह एलसीएम फाइंड करना है। ये जो क्वेश्चन है वो 8 मार्क्स में या 6 मार्क्स में पूछा जाता है। तो इसमें कोसेट प्रूव करने वाला जो 3 प्रॉपर्टी है उसके आधे मार्क्स है और आधे मार्क्स इन टेबल्स के होंगे। मतलब ये एक प्रॉपर्टी क्या है, मान लो अगर 6 मार्क्स में है तो 3 प्रॉपर्टी प्रूव करने के 3 मार्क्स होंगे और ये दोनों टेबल के आपको 1.5 मार्क्स मिलेंगे। अगर ये 8 मार्क्स में पूछा गया है तो 3 प्रॉपर्टी प्रूव करने के 4 मार्क्स होंगे और ये दोनों टेबल के 2-2 मार्क्स होंगे। ठीक, तो उस तरह ये क्वेश्चन आता है। एलसीएम मिल जाए तो टेबल कंप्लीट हो जाए तो लिख देना डन। किया कि नहीं किसी का? Just check your table. So we have, this is the LCM table, and see the all elements are belongs to the S30. There is no element which is the outside of S30. That means the GLB and LUB of any two elements from S30, it is belongs to the S30 itself. So therefore, here चेक कर लिया ना सबने टेबल. मैं आगे की स्लाइड ओपन करूँ. टेबल सबने चेक कर लिया. Okay. So here we have from this two table, you can say that for all AB belongs to S30, the GLB of AB and LUB of AB also belongs to the S30. So therefore, S30 comma D is a lattice as Poset. Okay, it is a lattice as Poset. Now, similar way, we have to prove that the n comma less than equal to is a lattice as Poset. So to prove this one, again, first we have to prove that n comma less than equal to is a Poset. So to prove that it is a Poset, we have to prove reflexive, then antisymmetric and transitive. पहले भी ये करवा चुका हूँ मैं एक बार. तो 2 मिनट का टाइम देता हूँ, आप अपने मुताबिक चेक कर लो. अगर किसी ने लिख के रखा है तो वहाँ से रीड कर लो. अगर लिखा नहीं है तो 2 मिनट लगेंगे प्रूव करने में, ज़्यादा नहीं लगेगा. For any x belongs to n, you can write the x is less than equal to x. Okay, so it gives you the reflexive relation. Okay, so here you can write for any x belongs to n, x is less than equal to x, so therefore x is related to x, then x is not equal to y belongs to n if x related to y, that implies x less than y, so therefore y greater than x, so therefore y cannot relate it to x. It is an antisymmetric, and for x, y, z belongs to n, x related to y related to z, that implies x less than equal to y and y less than equal to z. So that give you x less than equal to z. So that means x is related to z. So it is transitive. So therefore, n comma less than equal to is a coset. Okay. Now we prove that the two elements that if we take the two elements, then the two element for AB belongs to N, the GLB and LUB both are belongs to N. Now when we have less than equal to relation, what is the GLB and LUB? For less than equal to relation, we have GLB is a minimum number and LUB is a maximum number. So here GLB of A comma B is a minimum of A comma B and LUB of A comma B is a maximum of A comma B. Okay, ये रिलेशन के मुताबिक LUB एंड GLB याद रखना है. Okay, now for any two integers, positive integers, we can write as A less than equal to B or B less than equal to A. Okay, we have either A less than equal to B or B less than equal to A. Now if A less than equal to B means we consider that A less than equal to B, then we have minimum of A comma B is A and maximum of A comma B is B. Or if we have B less than equal to A, then minimum of A comma B is B and maximum of A comma B is A. Okay, if we have here A less than equal to B, then A is a smaller than B, so minimum is a and maximum is a B. If we have B less than equal to A, then minimum is a B and maximum is a. So in both case, the minimum value and maximum value is either A or B. So both are A and B already belongs to the N. We take as A and B belongs to N. So that means minimum number and maximum number also belongs to A. So that gives you that the GLB and LUB of A comma B belongs to N. So that prove that N is a N comma less than equal to is a lattice as Poset. Okay. So for any integer, we can write A less any two integer A and B. We can write A less than equal to B or B less than equal to A. If we have A less than equal to B, then minimum of AB is A, maximum of AB is B. If we have B less than equal to A, then minimum of AB is B, maximum of AB is A. So in both case, the minimum number and maximum number belongs to the N. So therefore, GLB and LUB belongs to the N. So that prove that N comma less than equal to is a Poset. Okay. So this lattice as Poset. Okay. See, if in an examination in place of N here the Z is given, then also we have the same proof. Here just you have to replace N by Z. Okay, because for any integers, any two integers, you can write that A less than equal to B or B less than equal to A. So in place of N, if you have given a Z, then you have to prove the same way. Just replace the N, capital N by capital Z. Okay, remaining all are same. So just prove the N less than equal to is a lattice as Poset. So we complete the two relation. Now the third relation we take. That the third relation, it is a subset relation. So what about the subset relation? What is the GLB and what is the LUB of the subset relation? Write in chat box. What is GLB and what is a LUB? Intersection and union. GLB of subset relation is a intersection and LUB is a union. Okay. So if we have the two subsets are given, then the GLB is a, so here the same way as we done in a S30 comma D, the first we have to prove that it is a poset. So to prove that it is a poset, here we have for any x belongs to P of A, you can say that x is a subset of x, so therefore x is related to x. Okay, then for x is not equal to y belongs to P of A, if x related to y, so that means x is a subset of y, and that means y cannot be the subset of x because x is not equal to y and x subset of y. So x is a smaller than y. So y cannot be a subset of x. So that means y is not related to x. Y is not related to x. So it is a anti-symmetric. Then x, y, z belongs to P of A if x related to y, y related to z. So that implies x is a subset of y and y is a subset of z. So that give you x is a subset of z and that is a x is related to z. So it is a transitive. Okay. So that means P of A comma subset is a poset. Okay. Now here to prove that the LUB and GLB are belongs to the P of A, we use the table here like we have done in a GCD and LCM. So here for P of A is a, for this example, P of A is a pi singleton 2, singleton 4, singleton 6, two terms 2 comma 4, then two terms 2 comma 6, 4 comma 6 and A itself. Okay, so here we make the same table here. Here we take the GLB, sorry, GLB of A comma B equal to A intersection B. Here we write the elements phi, then 2, 4, 6, 2 2 comma 4, 2 comma 6, 4 comma 6 and A. Sorry, थोड़ा. Then similar way here, phi, singleton 2, singleton 4, singleton 6, 2 terms, 2 comma 4, 2 comma 6, 4 comma 6 and A. Now here intersection with phi, it is always phi. Okay, intersection with phi of any set, it is always phi because phi does not contain any element. So intersection is always phi. Okay, then intersection of singleton 2 and singleton 2, it is singleton 2 itself. Then intersection of singleton 2 and singleton 4, then phi, here again phi, here singleton 2, here singleton 2, here intersection is phi because singleton 2 and 4 comma 6 there is no common element, and singleton 2 and A, then singleton 2. Okay, so this way you have to complete the whole table. So make both table for intersection and union, और जिसका बन जाए वो चैट बॉक्स में डन लिख दो, और जिसको बीच में कहीं पे प्रॉब्लम हो तो वो मुझे मैसेज करो तो मैं उसको फिर से एक्सप्लेन कर दूँगा. ठीक है, कंप्लीट कर दो जल्दी से ये दोनों टेबल. पहले इंटरसेक्शन का कंप्लीट करो, जीएलबी का, और उसके बाद यूनियन का करना. ठीक है, और अगर बीच में कहीं पे किसी को प्रॉब्लम है तो वो मुझे बोल देना. कम आने थोड़ा तो अभी तक किसी का मैसेज नहीं आया। इंटरसेक्शन वाला तो टेबल बन गया है स्क्रीन पे। यूनियन वाला भी हो गया कि नहीं? तो अंजलि का तो हो गया, दूसरे का? नीरज का भी हो गया। ठीक है, तो सारे एलिमेंट्स अगर चेक करो इसमें, in a union and intersection, the all elements are belongs to the P of A. That means the LUB and GLB both are belongs to the P of A. So it is lattice. Okay. Okay. So this is a lattice as a Poset. Now for n comma d, n comma d, तो उसके लिए क्या लिखेंगे? पोसेट तो आप प्रूव कर सकते हो, ठीक है। एन कॉमा डी, जैसे S30 कॉमा डी पोसेट प्रूव किया, तो उसमें जो यूज़ किए थे वही आर्ग्यूमेंट्स यहाँ पे यूज़ करने हैं। सिर्फ S30 की जगह n लिखना है। दैट x बिलोंग, फॉर एनी x बिलोंग्स टू n, the x can be written as x equal to 1 into x. So x divides x, therefore it is a reflexive. Then for any two x comma y belongs to n, if x divides y, then x is less than y, so y cannot divide x, and therefore it is a anti-symmetry. And for x divides y, y divides z, that means y equal to n m into x, z equal to n into y. Now replace the y by m into x, so you got z equal to n into m into x. So x divides z, so it is a transitive. So n comma d is a coset. Now how we can prove that the GLB and LUB is also belongs to here? अच्छा, जिसका यूनियन वाला टेबल बाकी हो कंप्लीट कर देना। जैसे इंटरसेक्शन का टेबल बनाया वैसे ही यूनियन का भी टेबल बनाना है। ओके, तो यहाँ कैसे प्रूव करेंगे कि दो एलिमेंट अगर लिए जाए एन में से, तो उस दो एलिमेंट का जीसीडी और एलसीएम दोनों एन में ही मिलेगा। For any positive integers, कैसे प्रूव करोगे कि भाई जीसीडी और एलसीएम दोनों का एन में है? So you have to prove that if we take the any two positive integers, okay, if we take the a and b belongs to n, then the GCD of a and b, for the GCD of GCD of a and b, we have the here we have four cases. Either a GCD is a or b, or any integer which is less than a and b, and the 1 or 1 if both are prime. Okay, so in all four cases we got the integer as a GCD. Okay, here if we have the here for a and b, we have four cases. The first is we take a divides b. If a divides b, then GCD of AB is a, and LCM of AB is a b. Okay, so it is belongs to the capital N. The second, we have the case is a b divides a. Okay, if b divides a, then GCD is a AB is a b, and LCM of AB is a. So again, GCD and LCM belongs to N. The third possibility is that A does not divide B, and B does not divide B does not divide A, but here we have A will be a sum C into D, and B will be a sum C into M, where C, M, and D belongs to N. Okay, we have this type, means like 8 and 12. If we take the 8 and 12, then here 8 does not divide 12, 12 does not divide 8, but 8 can be written as 8 can be written as 4 into 2, and 12 can be written as 4 into 3. So in this case, C is a 4, D is a 2, and M is a 3. Okay. So we have the third case is a like this. So here we have GCD of AB is a, what is the GCD of AB here? What is the GCD of AB? 8 and 12 का GCD क्या होगा? 8 and 12 का GCD 4. So here also we have GCD of AB is a C, okay, because C is the common divisor in A and B. So GCD is a C, and LCM of AB, it is C into D into M. C we take only one time in a multiplication. So in this case also, the GCD and LCM belongs to the N. So the last case we have here, that we have not this type of A and B. That means the last case is we have the common divisor of AB is a 1. That means GCD of AB is 1, and LCM is a AB, it is A into B, like 2 and 3, like 2 and 5, okay, 9 and 16, okay. These are the GCD is a 1, and LCM is a multiplication of two number. So in all these four possibility, the GCD and LCM both are belongs to the N. So therefore, for any two integer, the GCD and LCM are always belongs to N. So N comma D is a lattice as a Poset. Okay. तो ये स्क्रीनशॉट ले लो ताकि ये प्रूफ आपके पास है. पोसेट प्रूफ करना आपको आता है, वो S30 D में जैसे किया है वैसे ही करना है. ठीक है. ओके. So to prove the any Poset is a lattice, we prove that the GLB and LUB of the Poset, all elements of the Poset, it is also belongs to the that set. Okay. Now we take the practice from assignment also.